From this video onwards, we begin the discussion of statistics and econometrics for our exam. We will begin with basic statistics first, and after completing basic statistics, we will move to econometrics. For the CUET PG exam, this will be our syllabus. These first three topics are from measures of central tendency, and the remaining ones are from the topic of dispersion. Then there is correlation, and then there is sampling and probability distributions, and then simple regression model. So this will form a part of econometrics, and before this, all the topics will be covered under basic statistics. For the IIT JAM Economics exam, the coverage of statistics will be much more detailed. For example, here we see that a long list of topics has been specified under probability theory, mathematical statistics, hypothesis testing, and correlation and regression. So the first three topics, these ones will be a part of basic statistics, and this topic, or rather at least the topic of regression, will fall under econometrics. Also, you would have already noticed that the topics of measures of central tendency and measures of dispersion are not clearly specified anywhere here, right? But they were a part of our CUET syllabus. Also, for covering a few topics under probability theory, it will be useful if we have a good understanding of these topics. Hence, we will begin with measures of central tendency, cover this first, then we will cover measures of dispersion, and of course, these will be useful for our CUET syllabus, and then we will move to probability and other topics. In this video, what we will do is, we will understand what is statistics, and we will see a few terms and understand their meaning. These are the terms which are very frequently used in statistics and throughout this course. So let's begin with the basic question. What is statistics and why are we interested in studying this subject? There can be different definitions, but all of them will tend to say somewhat like this, that statistics is the science of learning from data. It consists of collecting, organizing, presenting, analyzing, and interpreting data. That means if we are given any data set and if we want to generate some insights from that data set, or if we want to draw some conclusions, the subject of statistics will be very useful for us. It can be used to forecast the future or determine the probability that a specific event will occur. It teaches us how to make intelligent judgments and informed decisions in the presence of uncertainty. So uncertainty is a part of everyday life, and if we want to make informed decisions in the presence of uncertainty, the subject of statistics will be very useful for us. It is used extensively in many different fields such as business, financial sector, policy making, medicine, biology, psychology, etc. It is also the foundation for other subjects such as data science, artificial intelligence, machine learning, etc. Moving on. Now, let's very quickly understand the meaning of a few terms. These terms are such that they will be used throughout this course. So, in the beginning only, let's understand what we mean by them. These are the concepts we will be discussing. So, let's begin with the first one, population and parameter. We begin with these terms: population, sample, census, parameter, and a statistic. So let's begin with the first one. What is population? It is the entire group of individuals or objects or events or measurements that we are interested in studying. It is the complete set of all possible items that share a common characteristic. As an example, let's say you want to study or you want to know the average height of all students at a university. Let's call it University X. In that situation, what will be the population? All these 10,000 students form the population. Of course, the interpretation of the word population can change with our study. For example, if we want to estimate the average time spent by a Mumbaiker traveling on road, in that case, our population will be the entire population of Mumbai. So, if we want to know how much time each Mumbaiker is spending traveling on road, we might want to visit each Mumbaiker and ask the data corresponding to each individual. As you might already guess, surveying or going to each individual and collecting data is not an easy task. That's why we generally make use of what we call a sample. So what is a sample? Sample is a subset of the population. For example, if this Venn diagram or if this circle denotes the population and we are interested in studying this population. For example, we want to know for this population the average time spent on road. But studying the entire population is sometimes difficult. That's why what we do is we study only a subset of this particular population and we call this subset sample. Using the data obtained in the sample, we try to estimate the actual data for the population. So remember, actually we are interested in studying the average time for the population. But because of difficulties in studying the entire population, for example, it can be too expensive or it can be impossible in some other situation. Let's say in this particular case, it is very expensive to survey all the population or rather all the Mumbaikars in the city of Mumbai. So in that case, we survey a few people, let's say 10,000 people. That forms our sample. And for the sample, we get the average time spent on road. And using this, we try to estimate this. So in this situation, this entire population of Mumbai is what we call the population actually. This subset that we study, it is the sample. The characteristic of the population we are interested in. For example, here we are interested in the average time spent by the population on road. This is what we call a parameter. For the sample, we have calculated this characteristics, the average time, and this is what we call a statistic. So using the statistic, we try to estimate the parameter. Okay. So now let's go ahead and see these things a bit more formally. So we know that population is often very large and sometimes hypothetical and usually too expensive or impossible to measure in its entirety. So what can be a case or an example in which studying the population is impossible? For example, let's say some biologist is doing a study on ants and wants to study some particular characteristic of ants. So for that particular study, the population will be all ants, let's say, in the world. So of course, studying all ants or visiting all ants or rather collecting data for all ants may not be feasible. Similarly, in some other situation, someone might be studying something about whales. So visiting all whales, collecting data about all the whales in the world, that might not be possible and not be feasible in most cases. That's why we make use of sample. So what is a sample? A sample is a subset or a smaller group selected from the population. How do we select that? That's a different topic altogether and we discuss that under sampling techniques. How do we collect samples? That's what is sampling techniques. So a sample is a manageable portion of the population that is actually observed or measured. We study the sample because measuring the entire population is often impractical. The goal for the sample to be the goal is that the sample should be representative of the population. If the sample is not representative of the population, then our results will vary. Okay. So as an example, say it is too time consuming to measure all 10,000 students that we discussed here. In that case, we can randomly select 200 students and measure their heights. This group of 200 students is our sample. So you can pause the screen and note down anything you want and then we move ahead. Next, we understand the meaning of census. It is a study that attempts to collect the data from every single member of the population. So the process of collecting data for the entire population, that's what is a census. The goal of a census is to obtain the true parameter without having to estimate it. So if we are going through the sample, then we are actually estimating the parameter. We do not know the true parameter. We are just trying to estimate it. But if we are able to collect the data for the entire population, then it is not exactly estimation. Rather, we are able to calculate the true parameter value. In practice, a perfect census is often very difficult and expensive to conduct. As an example, tracking down and measuring the height of all 10,000 students, that would be what we call a sample, a census. Next is a parameter. A parameter is a numerical value that describes a particular characteristic of a population. It is a fixed measure. So it can be like average height, average weight, or something of this type that describes the population. So it is a descriptive characteristic related to the population. Or rather, we can just say it is a specific characteristic of the population. Okay, you can read the remaining things here and then we move ahead. Next, we have the statistic. It is a numerical value that describes a specific characteristic of a sample. So earlier we were talking about parameter, and in that case we had said the population. So it is calculated from the sample data and it is used to estimate the corresponding population parameter. The word statistic often refers to a descriptive measure of the sample. Also note that the statistic is similar to the parameter in the sense that what statistic is to the sample, the parameter is to the population. So in the exam, they can give you a question in which they can ask you something of this sort. Okay. In fact, the statistic serves as an estimate of the parameter. In other words, although we are really interested in the value of parameter of the population, we most often may have to remain content with estimating it. That means estimating the parameter through a statistic from a sample that we have selected. Moving on. To understand these concepts better, let us discuss an example. Let's say we are interested in this population. And for this population, let's say we want to calculate some parameter. For example, let's say we want to calculate the average income for this population. But observing the entire population or collecting data for the entire population is of course very difficult. So for that, we use a sample. Remember, the way we collect sample is very important. If the sample is not representative, our results will not be reliable. So for the moment, let's say we have collected the sample in the correct way. And for this sample, we first calculate a statistic that will be the average income for this particular sample. And using this statistic, we will try to estimate the parameter, right? We will discuss these concepts in detail when we discuss sampling. Okay, so this is just an overview. Moving on. Next, what is the meaning of the term variable? We already understand what a variable is. We've discussed that in our classes on mathematics, but let's quickly go over it once again. A variable is the characteristic of the sample or the population being observed. For instance, if the statistical advisor for a city administration such as Mumbai is interested in the distance commuters drive each day to get to work, the variable is miles driven. Similarly, in a study concerning the income of all citizens in India, income is the variable. So in this particular situation, for example, we will have data like this. Let's say here we have the first column in which we have person name or person number. So it will be 1, 2, 3, 4 or so on for all names. So there will be data, let's say for 140 crore people approx here listed. And here we will have income. So income will be listed for each and every person. So in that situation, what we are saying is income is a variable because the value will vary for each person, right? Here is an alternate definition, but still the meaning remains the same. You can just read it and then we move ahead. As an example, consider this. In this data set, all these are variables: height, test score, favorite subject, number of siblings, and also student name. Moving on. Now, recall in the previous example, we had both qualitative data as well as quantitative data. So first, let's understand what they mean. Then you will be able to relate better that in the previous example, both these were present. A variable can be quantitative or qualitative. Quantitative means that if the observations can be expressed numerically, then it is a quantitative variable. For instance, income of all citizens is an example of quantitative variable. Other examples include heights of people, scores students receive in final examination, and the number of miles those commuters in Mumbai must drive each morning. So anything that can be described or expressed numerically is what we call a quantitative variable. On the other hand, for a qualitative variable is measured non-numerically. For example, the marital status of job applicants, either married or unmarried. So this is not a numerical data. Similarly, gender, hair color, religious preference. These are all examples of non-numerical measurement, and that's why we call them qualitative data. Okay, let's move ahead now. Next is univariate, bivariate and multivariate data. So uni means one, bi means two, and multi means more than one. Okay. So what is univariate? A univariate data set consists of observations on a single variable. For example, we might determine the type of transmission, whether automatic or manual, on each of 10 automobiles recently purchased at a certain dealership, resulting in a categorical data set. So in this particular case, we are considering only one variable. That's why we are calling it a univariate data. Only one variable is present in the data set. We may have a bivariate data when observations are made on two variables. For instance, our data set might contain height and weight pair of each basketball player on a team. So for each particular player, we will ask two questions, height and weight, right? And of course, multivariate means more than one. So that would mean that bivariate is a special case of multivariate, okay? Because multivariate means more than one and it includes bivariate. You can read the example and then we move ahead. We have already understood the meaning of variable. Now let's understand what are continuous variables and what are discrete variables. Variables can be continuous or discrete, and notice the spelling. The correct spelling is this. A continuous variable is one that takes on any value within a given range. So let's say we have data set such as this. A variable x can take any value between 1 and 2. So it can take 1.1 also, 1.11 also, 1.111 also, 1.1111 also. So if a particular variable can take on any value within a given range or within a given interval, we call that variable a continuous variable. Okay. On the other hand, if the variable is restricted to certain values, usually whole numbers or integers, then we call it a discrete variable. For example, if we are talking about number of students in a class, then number of students cannot be 1.2, 1.4, right? It has to be either 1 or 2 or 0. So either whole numbers or integers. Similarly, the number of cars sold by a company. Usually, discrete variables are a result of counting. And we say that continuous variable result from measurement, right? Moving on. These terms also we frequently encounter. What is the meaning of descriptive statistics and inferential statistics? So descriptive statistics deals with those things that describe a data set, and inferential statistics deals with those things in which we have to make inference to tell something about the data set. So there are primarily two branches of statistical analysis. Descriptive statistics is the first one. It deals with the process of collecting, organizing and presenting data in some manner that describes the data. So if we collect data, a huge data set, and we want to describe the data set, for example, we want to say what is the mean, median and mode, or we want to say something about dispersion. So these are different ways of describing a data set, telling more about data set, telling what is the mean, what is the standard deviation, what is skewness. So these are like measures of describing a data set. On the other hand, when we talk about inferential statistics, it involves the use of sample to draw conclusions or inference about the population. For example, when we use the income data of a sample of several thousand workers to estimate the average income of all 140 crore Indians, we are using inferential statistics. It involves making inference about the population based on the sample. Moving on. Next is sampling error, and here we are discussing it very loosely. We will discuss that in detail when we are discussing sampling. So what is a sampling error? Many a times the sample proves not fully representative of the population, and this leads to sampling error. It can be of two types, or there can be two possible sources rather. First is that it just happened by chance. So in that situation, it is not so harmful for us. You can just read these things, but primarily we are saying that it is not a systematic error, it just happened by chance. For instance, due to the luck of the draw in selecting the sample elements, it is possible to choose some atypical elements that misrepresent the population. What does that mean? For example, let's say you are interested in studying all the 10,000 students in a university, and you feel that it is not possible to collect data for all of them. So let's take a sample, and then you decide to take sample of 200 students. Now, it so happens by chance that all these 200 students that you select are from a particular ethnic background, which tends to have lower height as compared to other ethnic backgrounds, let's say, as a theoretical possibility. So although your intention and process was correct, but by chance it so happened that some atypical elements that do not represent the population correctly get selected in the sample. So this is also a case which can happen theoretically. We cannot rule it out. But the more problematic one is sampling bias, in which it is clear that your sampling methodology is such that it might lead to a bias. For example, let's say you wanted to estimate heights and you actually chose a particular gender only. So in that case, this gender alone may not represent the average height of the entire population. So clearly there is a problem with your methodology here. So basically, sampling error, we are saying that there can be two possible sources. First is that it just happened by chance. Second is that there is a problem with your methodology. Broadly, it means that the sample that you chose was not representative of the population. So that will lead to non-reliable results. We will discuss this in detail and more precisely when we discuss sampling. Next, let's understand the meaning of temporal and spatial. When classification is done on the basis of place, it is called spatial classification. And on the other hand, if the classification is done on the basis of time, then it is temporal classification. Cross-sectional data, what is it? It is a type of data collected by observing many subjects at one point in time. Remember, many subjects, but at one point. For example, population census. Last was conducted in 2011. So in this particular year, that means at one point of time, only 1 year, what was the data on different aspects of the entire population, right? So this is an example of cross-sectional data. So in this particular year, 2011, we went to, let's say, all the people in our country, and we asked, what is the name, what is your father's name, what is your occupation, how much you earn, all those things we collected data on. So in a particular year, we collected data on many subjects such as individuals, or in some other situation can be firms also, in some other situation can be countries or regions also. But in this case, we're talking about individuals. So we collected the data under population census about different aspects, many subjects, but in 1 year. This is what is a cross-sectional data. Then we have a time series data. Data on only one unit or a particular unit is collected at various points in time. For example, monthly data on consumer food price index. So we have all the items included in the food price index. On those, we have data being collected each month. So time is not just one. In fact, we have data each month on a particular variable. Then combination of these two is called pooled. So for different subjects, we have data on different time periods, right? There is a special case of that which we call a panel data. Panel data differs from pooled cross-sectional data across time because panel data deals with observations on the same subjects at different time periods. So what basically we are saying is that under pooled data. Under pooled data, we can have a situation in which we have data on different subjects in different time periods. For example, let's say we wanted to calculate the income of average income in a particular state of India, and we felt that collecting data on all the individuals living in a state is difficult. So let's take a sample. So in the sample, let's say we took data on 1 lakh people. Now, ultimately, the objective is to calculate the data for the entire state, the average income for the entire state. So we collected data on, let's say, 1 lakh people in the year 2011. Then we did the same exercise again in 2015. The objective remains the same, to calculate the average income of the state. So in 2015, we again collected data on 1 lakh individuals, but it is not necessary that the data on same 1 lakh individuals was collected as we had done in 2011. Okay, this is the case of pooled data. But when we talk about panel data, we are saying that panel data deals with observations on same subjects. That means the people whose data was collected in 2011, those very people were surveyed again in 2015 and maybe again sometime in 2020. So panel means same people collected data on different aspects, that is making it cross-sectional. So the cross-sectional element is there. That means in a particular time period, let's say 2011, we collected data on different aspects, or let's say different space. There is a spatial element, that means there is a cross-section. Then we have time period also, because we collected in 2015, in 2020, maybe again in 2025. So cross-section plus the data on time series, that's what is giving rise to pooled data. And if we are surveying the same subjects, then that is what is becoming a panel data. So make this difference clear. Now let's move ahead. Next is levels of measurement, and this is an important one because all the 9 other concepts that we have discussed before, we will be revising them, we will be revisiting them sometime during the course. But this 10th one, we will never revisit again. Hence, please make it a point to understand it well. Variables can be classified on the basis of levels of measurement. It can be nominal, ordinal, interval, or ratio. What is the primary difference across all these 4? It is what sort of mathematical operations can be done. So let's understand them one by one, then come back and read all these 4 once again and you will be able to follow. First is what we call nominal, or we also call it categorical. So a nominal measurement is created when names are used to establish categories into which variables can be exclusively recorded. For example, we have gender. It can be either male or female or the third gender. So notice these are categories and we are saying that we are using names. Now, instead of names, we can also use mathematical codes. For example, we can say that we will use 1 to denote female and 2 to denote males and 3 to denote the third gender. But still, the underlying distinction is not changing because these numbers serve only to indicate the categories and they will not carry any numerical significance. That means mathematical calculations will not be feasible on these 1, 2 and 3. Also note that nominal measurement carries no indication of order of preference. That means although we have denoted male using 2, in that sense we are not saying that 2 is better than 1 and 3 is better than 1 and 2. That's not what we are saying. That's why this is the first step in which we are trying to categorize data on the basis of only the categories that we have established, and these carry no mathematical significance, no mathematical calculations can be used, and also we do not indicate any preference through these. There is no order of preference. What is the meaning of order of preference? Sometimes, although the data is collected in categories, but they do indicate order of preference. For example, you've seen those surveys in which you have to respond by saying agree, disagree, or strongly agree and strongly disagree. So those are indicating some order of preference. In this first one, which is nominal or categorical, this is not happening. This will happen on the second one. So let's move to the next one. The second one is ordinal. It depicts ordering. Unlike a nominal measurement, an ordinal scale produces a distinct ordering or an arrangement of data. That is, observations are ranked on the basis of some criteria. We may rank a product or service as good, better, and best. Opinion polls often use an ordinal scale, such as strongly agree, agree, no opinion, disagree, strongly disagree. As with nominal data, numbers can be used, but like nominal data, the magnitude of numbers is not important. That means 1 and 2 and 3 are being used, but we are not saying that the arithmetic difference is of any use, right? We are not saying that 3 is thrice as good as 1. That's not what we are saying. That's why the arithmetic difference between these numbers or values are meaningless. So this is the second one. This is ordinal, in which there is some ordering. Earlier it was, the first one was nominal, in which there was no ordering. Now we have ordering. Now let's move to the third one. The third one is called interval. So how is this different from the first two? Variables on an interval scale are measured numerically and, like ordinal data, carry an inherent ranking or ordering. So what is the difference from ordinal here? Unlike ordinal rankings, differences between values is important. Thus, the arithmetic operations of addition and subtractions are meaningful here in this case. As an example, consider the Fahrenheit scale of temperatures. Not only is 70 degrees hotter than the 60 degrees, but the same difference of 10 degrees exists as between 90 and 100. So that means if we are saying that what is the difference between 60 and 70 degrees Fahrenheit, that is the same as 90 and 100. So that's why we are saying these differences matter here. Earlier, we have said that differences are not relevant. In the earlier cases, we had used 1, 2 and 3, but 3 was not, or this difference between 1 and 2 or 1 and 3 was not useful or not relevant. But here it is. So this is the third level. It is interval. Now let's move to the next one, which is ratio. So this is the fourth one, ratio. So how is this different from the third? Let's understand that first. The value of 0 was arbitrarily chosen in an interval scale. There is nothing sacrosanct about the temperature of 0. It is merely an arbitrary reference point. The Fahrenheit scale could have been created so that 0 was set at a much warmer or a colder temperature. So basically what we are saying that 0 had no significance. 0 did not mean a complete absence of something under the third case, which was the interval case, right? Also, we are saying that division is not making sense. That means 80 by 40, if we try to obtain, that makes no sense. This is under interval scale. So remember, we are calling it interval because only intervals, that means 80 to 60 or 60 to 80, the differences matter. Here we are calling it ratio because even this will somehow come into picture. So let's see what we have here. Unlike on an interval scale, a 0 on a ratio scale indicates total absence of the variable you are measuring. Of all the 4 levels of measurement, only the ratio scale is based on complete numbering system in which 0 is meaningful. Therefore, the arithmetic operations of multiplication and divisions also take on a rational interpretation. For example, when you are measuring length, area, population, cost, profit, inventories, these are expressed as ratio measures because here even the differences are relevant, and even if you want to do some multiplication, even those can be done. Also, 0 means complete absence of something. So if we are measuring length and if it is 0, then that means there is no length. The dimension is completely missing. Similarly, if you are measuring cost, 0 has a significance. That means there is no cost. Similarly, for profit, there is no profit. So 0 gains value. When we say 0 here, in this 0 means total absence of the variable. This happens only under the ratio scale. Now we come to the end of this introductory video. You can just go back and read chapter number 1 of the book Probability and Statistics for Engineering and the Sciences by DeVore. And let's meet in the next video.